Alright, this is about some basic terms before we start ray diagrams. I'm just going to kind of go through them with you real quick because we're going to use them a lot. So the first few that are on here, the focus. It says the focus is where rays very nearly all arrive at a single point. So I want to show you this little picture down here. It's got a bunch of parallel rays of light. So we've got a ray coming in here, ray coming in here, a ray coming in here. I've got four different parallel rays. You'll notice that once they hit the mirror, they all reflect all through a common point. Okay, that is essentially the focus where nearly everything crosses. Now, you'll notice up here too that it says that's also kind of the definition for the focal point. They are basically the same thing. Okay, it's just when something is in focus, that's when we say that all the rays are about at the same point. That point is what is called the focal point, where all incident parallel rays come to a focus after the reflection. That usually gets the little symbol F, or I'm sorry, capital F. The other thing that's on this particular drawing that you can see right now is something called the principal axes. Basically, it's something that would split the mirror right down the middle, or the lens, or something like that. And it's just drawn parallel to any other parallel ray that would come in. The last one on there is the focal length. It says it's the distance between the focal point and the center of the mirror. If we take a look at that, I have it marked here as from where the focal point is to where the mirror is. That is known as the focal length. It is important to understand that the focal length is half of the radius of curvature. So if this was a complete circle that went all the way around, okay, I should make it a little bigger like that. Okay, this point right here would be the center of that circle, or from here to here would mark the radius of that circle. Then halfway between is the focal length. Okay.